Hey everyone, and welcome to the third video in my One Joystick to Rule Them All series. In the previous two videos I showed you how to build cheap and simple adapters to connect Neo Geo joysticks to Atari compatible systems, Amstrad computers and consoles, the MSX and the Sega Master System. If that sounds of interest, then be sure to check out the playlist link below. In this episode I'll be covering the Sega Megadrive, or Genesis if you're in the US. This system's a little bit more complicated than the other ones I've covered, so in addition to the usual breakout connectors and joystick extension cable, we'll also need a handful of cheap components and a 74HC157 multiplexer chip. So just a quick recap. As I explained in my first two videos, the Neo Geo AES was a games console released by Japanese games company SNK in 1990, and is famous not only for the quality of its arcade ports, it's essentially a consoleized arcade machine after all, but also the build quality of the hardware itself. Personally, I'm a huge fan of the Neo Geo stick, and I think it's certainly a step up from the bundled controllers that we got with most of our computers and consoles in the 80s and 90s. Over the years, SNK released a couple of revised versions, known as the Kidney Bean Stick and the Neo Geo CD Joypad. This adapter provides the 5 volts that these need to work, so it should work great with those too. So anyway, why do we need to use a chip this time? After all, the previous adapters didn't need one. Well, back in the 1970s when Atari designed their joysticks, 4 directions and 1 button were more than enough for anyone, and these signals could easily be carried using the 9 wires of the Atari 9-pin connector, with some room for future expansion too. Fast forward 30 years and the games console has now become a much more complicated beast. In the case of the Megadrive, for the first time the start button comes into play, as well as 3 game buttons and the 4 directions of course. This makes for a total of 8 inputs. If we add a ground and a 5 volt feed we end up with 10 pins, but the Megadrive controller only has 9 pins, so we need a way to send 10 signals down a 9 conductor cable. This is achieved in the original controllers using something called a multiplexer. The multiplexer chip is a very common 7400 series TTL IC that combines multiple inputs into a smaller number of outputs. It achieves this by using something called the data select input, which is on pin 1 of the chip. The 157 will send a different input to each output depending on whether the console sends 5 volts to this pin, known as a high state in TTL, or pulls it to ground, which is known as the low state. If we take pins 12, 13 and 14 for example, we have the start button connected to pin 14, the C button connected to pin 13, and the output on pin 12. When the console pulls pin 1 high, the multiplexer will send the status of the C button to pin 12. When the console pulls pin 1 low, it will send the status of the start button to pin 12. The select pin is governed by the system clock, so on an NTSC 60Hz console this happens 60 times per second, and on a 50Hz PAL console 50 times per second. By hooking up an oscilloscope to pin 7 of the controller port, we can see this happening in real time. I'm not sure which console was the first to introduce this concept of polling for input, but I know that Nintendo's NES works in a similar way, and I'm hoping to cover it in a future episode, alongside the SNES. It may seem needlessly complicated if you're not too familiar with electronics, but it's actually a very simple and elegant solution. It also means that by chaining multiple multiplexers together, that we can have controllers with even more buttons and even multiple controllers on the same 9-pin controller port. As the 74HC157 that we're using is a TTL device, we also need pull-up resistors on the inputs to make sure that it's being fed the voltage levels that it's expecting. These resistors will all be 10K or 10,000 ohms. Also, as is usually the case with electronic circuits, we'll be needing a decoupling capacitor to make sure our electrical signals are nice and clean and stable. I'm using a 10 nanofarad tantalum capacitor as I had some spare, but the exact value and type isn't too important. Cramming all of this into a breakout connector would result in a huge mess, so in this case, and in the case of many of the consoles I'll be featuring going forward, we're going to have to put together a small interface board based around this multiplexer chip. As is usually the case on these more complex projects, I built my prototype on a breadboard just to make sure that the theory was sound. I ran into some issues with bad connections, which is always a risk with a cheap poor quality breadboard like mine, but I got there in the end. I have to say, I was really pleased with how well the prototype worked in Gunstar Heroes, which is one of my favourite games of all time, let alone on this system. Very, very promising so far. So now it's time to make this a bit more permanent, and a lot tidier and hopefully more reliable in the process. I'm going to transfer my circuit to perf board. You can use this or strip board, it really doesn't matter. I'm using perf board because I happen to have some spare. It's available in various sizes and can be trimmed down to suit the project you're working on, which I'll do later. It has copper pads on the back which can be joined together with solder, as we'll see shortly. We'll start with the chip in the centre and work our way outwards. I'm going to build this circuit around common power and ground rails, just like the breadboard prototype. With perf board, every pad is separate, so the connections between components are made using solder and the legs of the components themselves. It's kind of a halfway house between freeform soldering, where the component legs are soldered directly to each other, and a proper PCB. Because of this, I bend the legs in the direction of the component they're going to be connecting to, and not necessarily cut them short straight away. When snipping component legs off, it's often handy to hold onto them to create links with later. The up and down directions aren't handled by the multiplexer, but they do need pull-up resistors, so I'll add those now. I'll also add a link to what will become our power rail to power the chip itself using one of the legs we saved earlier. Now to create the 5V power rails on both sides by using the leg of the last resistor in line to tie the others together. I'm not sure if this is the best way to do it, but this is the way I learned and it's always worked for me. Now is a good point to inspect our work so far and make sure everything is connected up as it should be, and maybe more importantly, that nothing is connected to anything that it shouldn't be. Now we need to start hooking up our ground connections, so I'll create some more links for those using the offcuts. I actually added some wires at this point for the power and ground, but I changed my mind about where I wanted them later on, so they could be safely ignored. What is important to take away from this step is the addition of the decoupling capacitor, which directly links the power and ground rails. At this point, I'll also add two other short lengths of wire which we will be keeping. One of them connects pin 15 of the 74HC157 to ground. The second short length of wire connects the live rails on either side of the board together. With the board all wired up, all that's left is to hook up the inputs to the Neo Geo 15-pin connector and the outputs to the Megadrive 9-pin connector. For that, I'll use a couple of lengths of that SCART cable I chopped up in the previous episode. This time I'll just be tinning the ends that are going to be soldered. I had to add an extra wire to the joystick side, of course, and I thought for ages about the best way to do it. In the end, I decided to run an extra wire alongside the existing cable and use heat shrink tubing to keep it all tidy. I'm not really sure of a better solution without finding some 10-core cable, and only a very short length will be visible on the final product anyway. It would probably be a good idea to incorporate some strain relief into these cables too, maybe glue them down with some hot glue. I don't own a working hot glue gun at the moment though, so I'll drill and cable tie them directly to the perf board. I'll also take the opportunity to cut this perf board down to size. I found a small plastic box that's just the right size, so I'll use that to house the project, drilling some holes in the ends for the cables. Then it's just a case of mounting the circuit inside using PCB risers and wiring up the breakout connectors. I had considered spraying it black to match everything else, but to be honest, I quite like being able to see my handiwork. I'm not sure why transparent electronics stopped being a thing when the 90s ended. So there we have it. Slightly more complex, I know, than the previous adapters in this series, but a fun little electronics project and a great way to get some more use out of those Neo Geo controllers. It's a really great plug and play solution for all sorts of games and works fantastically well, even if I do say so myself. I'm getting loads of great feedback from people who are building their own adapters based on this series, which is always fantastic to see, including an Instagram post of a really nice modded stick from a user going by the name of RetroGlue 2.0. I also had some funny reactions to a picture I posted of my stick hooked up to my Atari 2600, so if you're interested in that kind of thing, I'll put my other social media links in the description below. In the next episode, I'm planning on building an adapter for the PC joystick port, as well as trying out an off-the-shelf USB solution. And further down the line, I'll be looking at the Atari Jaguar and Falcon, the 5200, and of course the Nintendo consoles. Finally, as always, I'd just like to thank you for watching. If you do build one of these adapters, please let me know, and I may even feature your work in a future video. Of course, if you have any questions or comments or suggestions at all, please let me know down in the comments section. It's your comments that make these videos what they are, and it's always great to read them. So if you did enjoy this video and you want to see more, please give it a thumbs up and subscribe to the channel, and I'll hopefully see you around.